Today again I'll try to explain to you the formula of stress. Basically this video gonna be so short. The purpose of it is just to explain the formula of stress, that's all. So let's start. Basically I just want to explain where we derive it from. So let's assume that we have a cubic member, okay? Let's assume like it is like this, okay? Excuse my drawings a little bit. Okay, so let's assume that we have this shape here, okay? And sorry, let me just fix this one here. All right, and we have a power or a force pulling on the side, okay? F, or basically P sometimes. They call P as pressure and F as just force, and another force pulling from the opposite direction, okay? So basically it is like this. So another force pulling on this direction, okay? So what will happen, what will this body experience? It will experience a stress within it. Basically the stress is to keep it from deforming. Now how do we measure this stress? We measure it by taking the area of the of the of the member, okay, and the force that is applied, okay? The force that is applied, okay? Force applied, okay? And after we take them, basically, we're gonna use this formula. This symbol called sigma, or basically sometimes, sorry, like let me just write it better. It is written something like this, yes. Sigma equals the force or pressure divided by the area, okay? Now make sure that whenever you, like, no matter what units you are given in the question, because like sometimes the force will not be given directly by Newton, will be like given by kilonewton or by meganewton, let's just say. Make sure you convert it into newtons before you apply it in the formula, in order for you to get away from any confusion later during in the calculations. And so this is for the force. You like, it's just as an advice, as a tip, make sure to change it into newtons, not kilonewton, not millionewton, not meganewton, when you using it in the formula. And for the area, it must be in meter square. And why I always tell my students to make it in Newton over meter square is so that they can immediately write it as in Pascal, because we measure the stress, okay? We measure the stress in Pascal, okay? And remember this symbol here is called sigma, okay? So Pascal equals exactly Newton over meter square. But like sometimes in the exams uh, you will be given like kilonewton over, like the force will be given in kilonewton, and the area will be given in like millimeter, okay? Basically they will give you like the length of one member and the length of the other one, and they ask you to multiply the two of these, like let's say A times B, in order for you to get the area of the member. So sometimes it will be given like millimeter by millimeter. So this will get you to a confusion later on when you're gonna write the Pascal. Let's see right now in the example what I'm meaning. So now we can see in this example that the member here has a force applied on it that measures in 50 kilonewton, and given the dimensions of the area, which is basically 20 millimeter by 20 millimeter. So what we will do is we will change the force to Newton, which is let's say 50 kilonewton equals 50 Newton times 1000, which equals 50,000 Newton. Okay, now we have 20, sorry, for the area we have 20 millimeter times 20 millimeter, okay, which will equals 400 millimeter squared. Okay, now for this one to change it, we basically gonna write it in this form. 20 millimeter is 0.02 meter times 0.02 meters, okay, which will equal 123.4 meter square. All right, so basically 4 times 10 to the power minus 3 minus 4 meter squared. Now let's use the formula to calculate the stress. So we have the sigma stress equals F over A, which equals, we have F, which is this one right here, 50 Newton, 50,000 Newton, divided by the area, which is 4 times 10 to the power minus 4. Or let me write it in this form. Oh, 0.0004. Okay, so let's plug in these givens the calculator. Basically 50,000 divided by 0.0004, this will give us 125 million Pascal, which we will write as equals 125 123 Pascal. In other words, it is 125 megapascal. So this is our solution. Alright, so you can take a screenshot of this to save it for you later as a note. So thank you for watching and have a good day.